Hello, my name is Joseph Williams, and the design pattern I'll be discussing today is the composite design pattern. So before we get started, this is a outline of what I'll be covering today. So I'm going to start with an overview of the 23 design patterns presented in the Gang of Four book, and then I'm going to dig a little deeper into details about the composite design pattern, and then I'll finish with a demo that shows how the composite design pattern can be applied to solve a real-world problem. So here is a chart that shows how the different design patterns, the 23 different design patterns presented in the Gang of Four book, can be grouped together. So you have three main groups: creational, structural, and behavioral. And then among those main groups, you have subgroups of class and object. So some of the design patterns are designed to be applied to classes, while others relate to objects. And the composite pattern I'm discussing today falls under the structural object section of the 23 design patterns in the Gang of Four book. The Gang of Four book defines the intent of the composite pattern as being to compose objects into tree structures to represent part-whole hierarchies. Composite lets clients treat individual objects and compositions of objects uniformly. And in terms of motivation, the motivating scenario will typically be when you want to represent complex hierarchical sets of data that are composed of simpler sets of data. If you have, let's say you're trying to represent the organizational structure of a company, you might have an HR group and an engineering group, and those groups might be composed of individual engineer nodes and individual human resource nodes that represent the people that work in those groups. A naive solution for representing this kind of data might be to create a lot of different classes for your primitive individual nodes, and then separate classes for different container classes. So you might have container classes for HR, engineering, finance, groups like that. The problem with that is you will typically end up with additional complexity in your application because you have a lot of duplication among your classes, and so the better solution presented by the composite pattern is to use a single abstract class to represent the interface for both your primitives and your containers, and then that results in reduced application complexity and a simpler user interface for your client to interact with your data through. So in terms of applicability, the Gang of Four book presents two main guidelines to keep in mind when you're trying to determine if you should use the composite pattern. First, you might use it when you want to represent part-whole hierarchies of objects, and then second, you might use it when you want clients to be able to ignore the difference between compositions of objects and individual objects. Clients will treat all objects in the composite structure uniformly. So so instead of the client needing to understand separate interfaces for your HR group and your engineering group and your individual engineers, the client can use a single interface defined in your component abstract class. So here's the sort of generic UML class diagram for the composite pattern, and you have your client that interacts with the component abstract class, and then the component abstract class defines operations that are overridden in your leaf and composite classes, and you'll notice that the component defines methods that are specific to composites, and those would be methods for actually manipulating leaf nodes like add, remove, get child, operations like that. And the leaves don't need to implement those methods because they only represent a single object instead of multiple objects, the multiple objects found in a composite. And yeah, so as I sort of mentioned before, the component defines an interface through which the client can interact with the objects in your hierarchy, and then the leaf sort of represents a primitive object in your organization. Or I guess if you're representing a business organization, the leaf would probably be an individual person working for your company, while the composite would be a group of people, or a parent component, and then the client simply interacts with your objects using the interface defined in your component abstract class. And yeah, so the clients use the component interface to interact with your objects, and the main distinction between the leaf and composite objects is that leaves handle requests directly, while composites forward requests to its child components, or composites forward requests to child components because they consist of leaves. So it sort of makes sense to do that, since leaves then handle the request directly. And then in terms of consequences, the pros and cons both relate to the simplicity provided to the users through the composite design pattern. So while the pattern makes the client code more simple, and it makes it easy to add new components because they follow the same interface defined in your component. Also, the trade-off is that the design might be too general, and so it might be difficult to restrict the types of components you're adding. And for instance, you might want to restrict your business components to a single supervisor, but because of the nature of the composite pattern, you might need to add additional code to your application to actually make those restrictions possible. So this is the hierarchical data for my demo. My demo is a basketball team management system. As you can see from the organizational chart, a team is composed of players, coaches, and a single trainer leaf. And this is the UML class diagram. As you can see, I created an abstract team component class that defines the interface through which the main client or the general manager will interact with the nodes in your tree structure, and then the leaves are separated into player and staff member categories. The staff member class will be used to represent either coaches or trainers. They're more generic type of leaf, and then the player class represents the player objects, and they have additional attributes for players like height, weight, and position. And then the composite class is the team class that consists of multiple leaves. So here's the actual code for this demonstration. This is the abstract class team component that defines the interface. Defines the interface for your composite and leaf nodes. You have your hire and fire methods for your composite nodes and your getters that are shared by both your leaves and your composites. And this is your player leaf node. It contains attributes specific for players like height and weight and position, and then it overrides the getters for displaying that information and printing details. And the generic staff member is very similar, or the generic team member, I should say, is very similar to the player leaf node, except it doesn't contain some of the methods that relate to players specifically. So it doesn't need methods that return height, weight, and position attributes, and that's why the team member class is used to define coach and trainer nodes. And then finally, the team component consists of an array list that contains multiple leaf nodes, and it also implements the hire and fire methods for adding and removing nodes from your structure. And then the main class you can think of as a general manager that interacts with the team. And for this scenario, initially you create a root node that represents the Detroit Pistons, and then you have two subcomponents, players and coaches, that contain player leaves and coach leaves. And so here are the players that are initially added, and then also a head coach and assistant coach are added to the team, and then finally a trainer. And so if you run the project, so you'll see that initially the details about the team are printed, and so you'll notice that the power forward for the team initially is Rasheed Wallace, and you also have your coaching staff and your trainer. And then later the general manager decides to hire a new player, a new power forward player, Blake Griffin, and release the Rasheed Wallace node. And so after the details are printed again, everyone on the team staff remains the same, except the Rasheed Wallace node has been replaced with the Blake Griffin node. That concludes the demo for my implementation of the composite design pattern, basically showing how you can use it provides a simple interface for interacting with hierarchical data, in this case for a general manager managing the players on a basketball team. And finally, so in terms of my references, the content of this presentation is essentially a summary of the Gang of Four chapter on the composite pattern. So for more details and examples, the best place to look is probably that book. And then my demo is based on what I learned when I studied the menu hierarchy examples found in the Head First Design Pattern book. So that's also another a valuable resource for learning more about the composite pattern. Anyway, that concludes my presentation and demonstration of the composite design pattern. Thank you.